Let's take a look at the randomization test option in the crossed orderings pattern analysis procedure. Now, we've been examining the relationship between these self and other extroverted ratings, and we're expecting high agreement between the two sets of ratings or the two sets of observations. So let's go ahead and turn on the randomization test. Let's leave the number of trials here set to 1,000. Now, if you have a large data set, I'd recommend bumping that down to something like 10, run the analysis to make sure it's not going to take too long to iterate through. But with 142 cases, this is going to fly right through the iterations. We'll leave the all observations set as the default here. And then let's go ahead and select the Save Randomization Results so we can take a look at the randomized PCCs that we're going to generate from this analysis. Now, what's going to happen here is with the first and second ordering selected, the algorithm or the program is going to go through and randomly shuffle the second ordering. In this case, it's the extroverted other rating. So it's going to randomly shuffle all of the numbers in this column. So it's haphazardly pairing the two sets of observations, the extroverted self and extroverted other rating. So it's haphazardly pairing those. It's like pairing them by chance, like a chance encounter between the two sets of observations. So it's going to randomly shuffle them, compute the PCC, and set that aside. Randomly shuffle the extroverted other ratings again, that whole column, compute the PCC, and set it aside. So it's going to repeat that process, in this case, 1,000 times. So we're going to get 1,000 randomized PCCs, and then we can compare our observed PCC to those randomized PCCs. Again, we're going to save those randomized PCCs because we've selected this option. So let's go ahead and run the analysis. You see it iterates through quickly 1,000 times. I'm going to move this up a little bit so we can see what's going on. So here is the original PCC, 49.30%. It was 70 out of 142 individuals correctly classified. Here we get the randomization results. The PCC is just repeated for convenience. Here is the 1,000 trials. And then here we see this values greater than or equal to observed percent correct. So our observed percent correct was 49.30%. That's our PCC. It's here again. Now, how many of the randomized PCCs equaled or exceeded that value? In this case, none. None of the values were 49.30% or higher. In fact, the highest PCC, randomized PCC, you can see here is 46.48%. And the lowest value is 22.54%. So since we did not meet or exceed 49.30% a single time, the chance value is reported as less than 1 in 1,000 because they had 1,000 trials here. So let's go take a look at those randomized PCCs to understand again a little more clearly perhaps what's going on. So notice I've got a new data set that's been created here, and I'll go to the Define Orderings window. It's already been maximized here. Here are the PCCs. Let's turn on the distribution. We can see it's kind of a normal looking distribution, but that doesn't really matter in observation-oriented modeling. You don't assume normality of PCCs here. We see the lowest value. There were two instances of 22.54. Here is that highest value, 46.48, and there was only one instance of that. Then we had a 45.77 and so forth. Looks like most of the values fell between 37.32 and about 30.28. But again, here is the maximum value that we saw from the randomized PCCs. These are the randomized PCCs. Not a single time in 1,000 trials, 1,000 randomized versions of the data, did we see a value equal to or greater than our observed PCC of 49.30%. So what this tells us then is that if we just haphazardly connect our data, the two sets of observations, pair them by chance, like a chance encounter between the two orderings or two sets of observations, then it's very difficult to obtain a PCC or a pattern in the data that can give you a PCC that's 49.30% or higher. So that then helps us to rule out physical chance as a potential explanation for the pattern that we see in the data. Now, if we can rule out physical chance as an explanation, then that helps us to move one step closer to offering a true causal explanation for the pattern that we see in these personality data.